Hi everyone, I'm Jennifer Van. Oh gosh, it's at the middle. Oh, sorry. Okay, all right. Let's go to the beginning of that. Scaling my first enterprise React app. Thank you for coming to this talk. It's a one-track, so you have to be here anyway. I know that my bio is a little scattered. I honestly thought it was just like, oh, it's a cute little thing. I'll just write some stuff about me. I didn't know I was supposed to write about like what I actually do. So that's a common question, so I thought I'd clear that up for you all. I think this answers a lot of questions about me. I'm a front-end developer as well as a machine learning engineer at Capital One. So today I'm going to be specifically talking about front-end development. And let's start unpacking this title, Scaling Enterprise React App. I know there's a lot of buzzwords in there. So let's start with enterprise. What does that mean? And maybe you've seen this meme around. Yeah, I program in Java. Let's zoom in on that. I'm in this enterprise dev job for the past 5 years and I'm slowly deteriorating. This isn't a meme, it's a legitimate call for help. And you can see the exact moment that the hot dog starts to die. Help me, we're talking about enterprise. So I kind of wanted to break down like what does that actually mean? What are the hallmarks of enterprise products? One of them is that it persists. So it's not something that you work on for a few months, chuck over the fence, and kind of forget about. It's something that's going to stick around for a long time, years, something that you'll own, and so it's going to live forever, basically. So you kind of have to own the mistakes and really invest in long-term persistence and robustness of what you've built. On top of that, it's going to grow. So if something is going to be around for a long time, you can basically bet on the fact that it's just going to only get bigger from here. And the last thing is that it's tested. And I know that a lot of us talk about testing, and we say that we totally do it, but you got to do it, especially in an enterprise environment where that's part and parcel of deliverables. So let's continue unpacking my title, Scaling Enterprise React App. What does it mean to scale? So I just talked about growth, and what does it mean to not scale correctly? And it basically feels like this. So when you have things grow, specifically 3 different portions of something growing in your product, your dev team, and your user base, scaling means that things stay fast, things stay usable. So I wanted to walk you guys through some of the things I learned along the way that I hope also help you continue growing in a way that your app still stays very fast and very usable. So what was our use case at Capital One? So we were building a monitoring dashboard that took in terabytes of data per day, had multiple users making concurrent changes to things, and we had an app for that already, but they told us that it was, these common complaints that were unacceptable for a product. One of them being that as soon as they loaded it, as soon as they typed it into their browser, the web page would take up to 10 seconds to load. And this is absolutely unacceptable for a product in enterprise because you don't even know if it's working. And even when they did get into it, they would click on something, it would be unresponsive, and it would take 3-4 seconds to get an interaction response from that. And again, it's because there was so much data coming in and so many things that had to be handled in the state. And so we wanted to build it from the ground up. Very luckily, we were able to do a greenfield app. We thought, okay, we hear your concerns, but I have no idea what I'm doing. How do I build this in a way that still stays fast? Because that's kind of the problem that everyone has, that as things get bigger, how do you keep them fast? How do you keep them usable? So as I said earlier, those 3 tenets of scaling, product, dev team, and user base, as your product grows, how do you keep React fast? One of those things is, and this is going to be a crux for many other performance optimizations that you'll want to do. From the get-go, defining presentation and container components. If you don't know what a presentation component is, it's basically the idea of like a dumb component. So it just only receives these props, only concerned with the way things look, and that's pretty much it. It's kind of dumb. And then there's a container component. And this one is going to be manipulating data, concerned with how things look or how things work, and it'll pass it down to that to something that's dumb as a child component. And I know that in the beginning, when you're starting a project, you can feel like you're being inundated with a lot of information. And a technique for approaching presentation and container components is that you can actually just start building things with just presentation components only and start to feel kind of the squeeze and the difficulty of keeping things handled in a performant way. And so how do you measure that your performance is doing better with any improvements that you make? And one of those is utilizing the performance timeline to determine bottlenecks. So a way that you can do that is appending React perf. So I can actually do that here for my presentation. So you inspect, you press performance, you wait a long time, press record, start doing things. Maybe don't spend like more than 20 seconds doing this because it kind of is a lot of overhead, and then pressing stop. And then wait a little bit of time. So what you see is that, oh, it went back on both. Okay, awesome, great. So what you end up seeing when you open up the user timing is you start to see the component tree down here. And something that you want to see is kind of this pyramid. So a parent component having children components only rendering when they need to. And that kind of goes right into my next topic on that, is removing those unnecessary renders, because that'll be a lot of a bottleneck for people, is that when you pick up something with React and you pass down props from the parent, people think, okay, that's great. I'm gonna use React because I've heard all about this virtual DOM, I've heard about the reconciliation. I know that if a child component changes, that's the only thing that'll change. And it's performant, it's optimized. But if your parent changes it anyway, it actually causes all of your children components to change as well. And so there's a lot of unnecessary rendering, a lot of overhead if you don't take that into account. And you can notice that if you go back to this timeline, and your component tree kind of looks like one big block all the way down. And that, if you're not expecting your child to render that often, you're basically noticing that something's wrong with your child. It's updating unnecessarily so. And the way you circumvent that is by using should component update. And so you'll say something like, if the props of my children actually change, then do something. If not, don't do it. And then from there, those are the three things you can do to actually make your app faster. The next two things I'm going to talk about are things that make your app seem faster. So one of those is prioritizing network calls. So a frustrating thing that I just talked about was that our users were using this monitoring tool, and they weren't getting a response fast enough to know that the web app was actually working for them. So something that you can kind of do to give the illusion that it's working faster is that you can render to the page the minimum style needed so that they know that something's happening, that they're getting a response at all. So if you get something like HTML and some text up there, immediately, even if your user can't necessarily interact with it immediately, they know that there's a response, it's alive, they can interact with it soon enough, and it kind of buys you some time. And so there's a priority of rendering elements, and the highest one is HTML, so that gives you that structure on your page. And I just talked about how users want to see something on the page, so not only the HTML, but it's really important that the user sees font as well, something with text. And I noticed that with our app, when we were loading fonts, that it was actually getting deprioritized all the way to the bottom, because we usually, with fonts, use some sort of linked reference style sheet. And so all the style sheets would first get loaded, and then the font would get pulled in at the very end and wasn't being actually loaded until the selector element was actually used. So that sucked. So how do you prioritize network calls? Again, you would want to open the dev tools, and you can actually go into the network tab and click on like a right click here, and you can pick priority. And you can start to see how your network calls are being prioritized, and you can start to prioritize yourself what you think the user needs to see immediately to know that your page is working. And so a way to escalate that text priority is by adding this very simple thing to your style sheet. Is just preload, so that if that's a local font, just add preload. If it's something that's remote, if you just add pre-connect, it immediately escalates your font to the very beginning and gives the illusion that your page is working a lot faster than it is. Or, just chunking things in a certain priority. Yep, add preload for local fonts, add pre-connect for remote fonts. So as your product grows, how do you keep React fast? The last thing is code splitting. And there's a lot of documentation out there on that, so I'm not gonna go into that too deep. It's been done much better than I could ever do it by React training, so I'll release these slides at the end, and you guys can definitely go through that code example. So I just talked about React in my product growing, so as my product grows, how do I keep Redux working as fast as possible? One of those things is understanding that set state is okay. You don't need to put everything in the global state. And I know that you've heard all the time, but it's bad, I should never do that. But if you're kind of putting everything into your global state and it doesn't need to be there, that's some overhead, there's a level of indirection that you have to add. And so if it's truly, and that kind of goes back to the pivot point earlier where we said, hey, I'm gonna define presentation and container components. And you can start to see that some things are just dumb and don't need to know about anything else. And that's a really good use case for just saying, hey, this is a set state situation. I don't need to make all of these action creators and whatever to push it into my global state. I can just keep it local, and that's perfectly fine. Don't bloat your global state if you don't need to. As well, connecting at multiple components. So earlier I said if you have something at the parent and it changes and it forces all of your children to re-render, it can actually be helpful if you connect at multiple components and just pass down what you need at each of them. And so you're kind of circumventing these unnecessary renders between the middle components when all you really want is the very sub-nested child to get what it needs. Another one is normalized state shape. So we had this discussion, should we have a denormalized state shape or should we have a normalized one? And we actually got a 10-time performance improvement by using a normalized state shape because of the diff between the trees. Basically, if it's super nested, it just takes longer. So what does a normalized state shape mean? So that monitoring tool that I talked about, we have things like alerts. And each type of data gets its own table, and this is highly inspired by the Redux docs on normalized state shape. And so there's comments that also has its own table of different comments. There are users like Legolas and Gimli, obviously using Capital One's alerting monitoring tool. And each object gets its own ID as a key. So you can see they all have their own ID. And then the value is the object itself. And so it's a very flat representation of state, and it helps performance quite a bit. So now we're going to shift to when your dev team grows, how do you keep, again, scaling? How do you keep things fast for your development cycle? And one of those is file structure. And so we started off with a common file structure that I think you'll see in Create React App that says, hey, there are some components, there are some containers. I'm going to start separating things into presentation and the other type of component that I'm forgetting right now, or containers and presentation components. But as you're like, okay, I'm gonna put it here, and I'm gonna put it here, it all makes sense, like some of these are dumb and some of these are smart. But then when you start adding more and more components, and then you wanna change one thing, there's a level of indirection where you have to kind of flip back between containers and components and try to understand, okay, so these deal with these, so I have to go to this folder, and now I have to go back around and make sure that I know all the names of these components deal with each other. So we actually just kind of got rid of that. It's just super confusing when you're trying to change something. And so we just have one component folder, and there are different features in them, and then in each of those component files, you have the presentation and the dumb components within them. And this added a lot of agility to our team, because if you wanted to make a change, everything that you needed was right there in that feature. It wasn't like something where you had to ask somebody else, hey, I changed this one file and I'm not sure, do I have to go to containers, and then what's connected to what, basically. It's pretty much laid out in this file structure. It just makes sense. And as your dev team grows, another thing is documentation and onboarding. And I know this is just like my own plea, like please write good documentation. If you want someone to come onto your team and write new features and keep building things, because you're not always gonna be on that team forever, and this product is gonna live for a long time, you have to make sure that somebody else can come on and pick it up. And I did wanna point out for onboarding, I think you've heard a lot here today that it's not just about code, it's about the people that you're working with. That's what matters. And so on our team, something that was radically different to me was that our manager baked in for us time to learn React and Redux, because it was something that wasn't super common for us. So I think that when you make this concession for short-term speed in the interest of long-term persistence and robustness of your code, it pays off in dividends, because now everyone's just working at a very fast pace. And static type checking. So Evan just gave a really compelling presentation on Elm, and specifically about the beauty of static type checking. So whether or not you use these, your JS still has type. So if you want to catch these runtime errors, whether or not you want to use them, they still exist, and you still have to make sure that things are consistent. And it kind of is like a documentation in and of itself. People kind of understand what's to be expected from different types, from different inputs. And as finally, the last piece I want to talk about was, as your user base grows, how do you maintain app usability? So I just talked about your product being fast and your dev team being fast, but you can't have that conversation about performance if people can't use your app at all. And so one of the things I want to talk about was accessibility. And so why does accessibility matter? I think a lot of us here, we should make things accessible. And this is one pretty famous example that's going around in the web right now, where someone can't use a hand soap dispenser. And I just wanted to ask you guys a question. What's the first thing you do when you wake up in the morning? I heard check, so check your phone. Yeah, I would say 99% of us check our phone. And then once you're done checking your phone, you go to work, you check your email, you're constantly interacting with tech. I would say like 90% of your day is dictated by technology. And when you as a person are not included in that technology and you can't even use it, what's the point if your app is fast? So like one story that really stuck with me is that, in particular, when operator voices were first being used for telephones, robotic ones, it was never tested on a woman's voice, and they actually used to hang up on them because it was the same dial tone as a hang up one. So when you make something, especially at Capital One, and you're dealing with finances, you want to make sure that people can use it. And so creating an accessible product means it needs to be fully functional with just the keyboard only. It also needs to have sufficient color contrast for users with low vision, and there are plenty of tools out there that can tell you whether or not your colors are contrasted enough, and that there's a screen reader possible. So that means that screen reader libraries can actually go through your app and read out what's actually happening there. And a way to do that is to begin enabling web to assistive technologies. One of those is labels for screen readers with ARIA, so you can actually just add that in. There's plenty of tutorials online for that. Another one is focus control for keyboard interaction. So I just wanted to go over, okay, let's just try it now. Let's pretend that we have to interact with this website purely through keyboard alone. And that's a simple test that you can run yourself. Let me see if I can get onto React Rally. Oh, fantastic. So the idea here is that you just want to press tab and see, with just tab, maybe a few arrow functions, and enter if you have full functionality to the website. And again, as your user base grows, you're not sure what people will be able to interact with, so you have to kind of be able to anticipate those needs. And yeah, we're able to go through oh, here's my email address, sign up, more about React Rally, and that highlighting around the links is actually imperative to an accessible web. And testing for accessibility. So let's say like you don't have accessibility baked in because that's a long-term investment for maybe users that you haven't anticipated yet or met yet. We just went over keyboard testing, but a few other great libraries are React Ally and React Axe. And so React Ally in particular will actually port into your dev tools and throw warnings when components aren't accessible. And testing in React and Redux, I just talked about, oh, we should all do testing, and this is not good enough when you go to your customer and say, it works most of the time. I think that there's plenty out there about it. I know that you have to do it. I know that there's Jest out there, but for us, I just wanted to kind of gloss over and say that we use Mocha, Chai, Enzyme, and Cinnamon, and it's been perfectly fine for us. But just definitely make sure that that's something you do along the way and not just kind of kick off to the side. And I'm really bad at ending presentations, so I just want to put this up here. I was told I could just walk off the stage when I was done, but I hope that you all learned something that could help you build an app that is persistent, robust, fast, and is usable. Thank you.